Hello students, welcome. Previously, lesson 21, form 3 topic 2, we are dealing with direct titration under the aim of determining the unknown concentration of the analyte. We have done example number 6. So today, lesson 22, we are going to do part B, or the second aim of direct titration, which is determining the unknown volume of the analyte. Examples. Number 1, we are told 20 centimeter cube of 8 grams per decimeter cube of sodium hydroxide completely neutralizes 0.05 molar dilute sulfuric acid. Full stop, determine the volume of sulfuric acid. So in our case, we are having sodium hydroxide, its concentration and also volume. But on the other side of sulfuric acid, we only have its concentration. That means we don't have its volume. So we are told to look for the volume of the sulfuric acid. So we have to start with sodium hydroxide. Let's get the molarity of sodium hydroxide. So we were having several formulas of calculating molarity of a solution. One of them was concentration in gram per liter over the RFM. So here they have given us concentration in gram per liter. So we can start looking the RFM of sodium hydroxide. RFM of sodium hydroxide. Sodium, RM of sodium is 23, the RM of oxygen is 16, the RM of hydrogen is 1, which will give us 40 as our relative atomic mass, the relative formula mass of sodium hydroxide. So using the formula, we can write molarity. Molarity will be equal to concentration in grams per liter over the RFM. So if you check, we have been given concentration in gram per liter. It is 8. Then we divide by the RFM of sodium hydroxide, which is 40. So here we are going to get 0.2 mole as our molarity. So if we get molarity of sodium hydroxide, we are supposed to look for the number of moles of sodium hydroxide. So moles of sodium hydroxide. So if I have the molarity of sodium hydroxide and the volume of sodium hydroxide, moles will be equal to molarity times volume used over 1000. That will be the formula for calculating moles. So molarity of sodium hydroxide is 0.2 multiplied by the volume used of sodium hydroxide, which is 20. It is given there. Then we divide by 1000, which is in the formula. So here we are going to get 0.004 moles of sodium hydroxide. So that's the number of moles of sodium hydroxide. So if we have the number of moles of sodium hydroxide, we can as well get the number of moles of sulfuric acid by using the mole ratio, using the reactions. So we can have the reaction between sodium hydroxide, which is solution, plus sulfuric acid, dilute sulfuric acid, which is solution or aqueous. We are going to get sodium sulfate, which is aqueous, plus water, which is liquid. So to balance the question, we have to put 2 in the side of sodium hydroxide, and we have to put 2 in the side of water to balance the question. So let us see now the mole ratio between sodium hydroxide ratio sulfuric acid. So the mole ratio is 2:1. There's 2 in the side of sodium hydroxide and there's 1 hidden in the side of sulfuric acid. So if we have the number of moles of sodium hydroxide to be 0.004, that means we can get the other one. So we cross multiply. We are going to have 0.004 times 1 divided by 2. So here we are going to get 0.002 moles of sulfuric acid. So that's the number of moles of sulfuric acid. So next, we are supposed to calculate the volume of sulfuric acid. So we can use the formula for volume used. Volume used is equal to, or can be used by the formula, which is moles times 1000 over molarity. So we can use that formula to calculate the volume of sulfuric acid. Okay, to put our values in the formula, the number of moles is 0.002 multiplied by 1000, which is in the formula, then divided by the volume used. I mean the molarity of sulfuric acid, which is given as 0.05 mole here. You have been given the molarity. So we're going to say divided by 0.05. So here we are going to get 40 centimeter cube as the volume of dilute sulfuric acid. Okay, we are done with that question like that. We go to question number 2. So we are told a given volume of 0.2 molar sodium hydroxide requires exactly 20 centimeter cube of 0.1 molar sulfuric acid for complete neutralization. So we are told calculate the volume of sodium hydroxide that reacted. So we have to start first of all getting the moles of sulfuric acid, because we have the volume of sulfuric acid and the molarity of sulfuric acid. So we can get moles of sulfuric acid. So moles of sulfuric acid. So what is the formula for calculating moles? We say the molarity times volume used over 1000 is the formula for calculating moles of sulfuric acid. So the molarity is 0.1 multiplied by the volume used, which is 20, then divided by 1000. So here we are going to get 0.002 moles of sulfuric acid. Okay, next I have to go to the number of moles of sodium hydroxide, and that one I can get by using mole ratio after I write the equation for the reaction between sodium hydroxide and also dilute sulfuric acid. So the reaction will be sodium hydroxide aqueous plus sulfuric acid aqueous, giving me a product of sodium sulfate aqueous plus water, which is liquid. So to balance the equation, we put 2 there, and we also put 2 in the side of water. So now we can use the mole ratio of between sodium hydroxide ratio sulfuric acid. It is 2:1. So we know the number of moles of sulfuric acid, it's 0.002. What about the side for sodium hydroxide? So we can cross multiply. So the number of moles of sodium hydroxide will be 2 times 0.002 divided by 1, which is equal to 0.004 moles of sodium hydroxide. So if we have the number of moles, we can get the volume of the sodium hydroxide used by using the formula volume used is equal to moles times 1000 divided by molarity. So in our case, the moles of sodium hydroxide will be 0.004 multiplied by 1000, which is in the formula, divided by the molarity of sodium hydroxide, which is in our case 0.2. So we are given 0.2 as our molarity of sodium hydroxide. So using the calculator, we are going to get 20 centimeter cube. 20 centimeter cube as the volume of the sodium hydroxide. So next, we are going to go to example 3. In example 3, we are told to calculate the volume of 0.6 molar sulfuric acid solution needed to neutralize 30 centimeter cube of 0.2 molar potassium hydroxide. So we are going to start first of all the number of moles of potassium hydroxide, because we have the volume and we have its molarity. So we can get moles of potassium hydroxide. Moles is equal to molarity times volume used over 1000. That will be the formula for calculating moles. So this will be equal to the molarity of potassium hydroxide is 0.2 multiplied by the volume, which is 30.0, then divided by 1000. So here we are going to get 0.006 moles of potassium hydroxide. So next, I have to get the reaction between potassium hydroxide and also sulfuric acid. So potassium hydroxide aqueous plus dilute sulfuric acid aqueous. I'm going to get potassium sulfate aqueous plus water, which is liquid. To balance the equation, we put 2 there and we put 2 here. So thereafter, we can get now the mole ratio between potassium hydroxide ratio sulfuric acid. It is 2:1. This 2 here and this 1 here. So we know the number of moles of potassium hydroxide, which is 0.006. So what about the number of moles of sulfuric acid? So we are going to say 0.006 times 1 divided by 2. This will be equal to 0.003 moles of dilute sulfuric acid. So if we have the number of moles of sulfuric acid and we have the molarity of sulfuric acid to be 0.6, that means we can get the volume used. So volume used will be equal to moles times 1000 over molarity. This will be equal to the moles or the number of moles of sulfuric acid, which is 0.003 multiplied by 1000, which is in the formula, divided by the molarity of sulfuric acid, which is 0.6, divided by 0.6. So here we are going to get a volume of 5.0 centimeter cube, which is the volume of dilute sulfuric acid. That's the end.